okay? So like JIT.qt is for QuickTime, JIT.gl is for OpenGL. So JIT.gl render, okay, is the render context, okay? You give it a name. This is important. It should have a name, otherwise it'll make up a name and you're not going to like the name it makes up. So we're going to call this, Bob, right? Okay. So we've given it a name, we called it Bob. It's very exciting. This object, the most important thing this object does is it handles the messages to do things like erase the world and draw the world, sort of like big picture commands, right? If that makes sense. It doesn't really sweat the small stuff, but this is the object that gets the message to say go and show it, right? So that would be a metronome, but we're going to use a special kind of metronome. We're going to use something called a Q metro. And a Q metro is a chill metronome, basically. What it is it's a metronome that you can set as fast as you want, and it has a special way of handling the bangs, so that an object on the receiving end, okay, if it's too busy, it can just ignore them instead of creating a backlog. Okay? Because the OpenGL, the render object, this thing actually talks to your graphics hardware. So if you hook up a metronome to it that's too fast, right, the maximum speed of your graphics hardware is the refresh rate of your screen. Okay? So if you're hooked up to your projector that's going at 60 hertz, you can't get more than 60 frames a second. It's impossible. It won't let you do it, right? So if you send it bangs and ask for like 300 frames a second, it'll start backlogging and backlogging and backlogging, and then you turn off your metronome and it'll keep rendering for another like 30 minutes, flushing the queue of backlogged bangs. Does that make sense? Right? So the Q metro is a special kind of metro that, like, when a renderer gets it, if it's free, it'll draw, right? But if it's busy, it'll be like, dude, not now, and like that bang will go away instead of getting added to a queue. You also use a Q metro to talk to things like serial devices. So if you're pulling an Arduino, you use a Q metro for the same reason. If you're setting the metronome faster than your serial port baud rate, you don't want a backlog of message requests. So it's like a hardware thing. So I'm going to hook this up. This is a chill metronome. And now, what do I need? I need number 2. I need a viewport or a window. So I can use a JIT window object, and I give it the name Bob. JIT window Bob. Gives me a title bar. It's called Bob. These two objects do not need let's viewport into context. These two objects do not need to be connected like with patch cords. They're both called Bob, so like that's enough, right? Because they're both called Bob. This window knows to show you the contents of this context. All right. So if I turn on the metronome, not sure what'll happen, but yeah, that was hard to see. Everything turned kind of a medium gray. And I should have gotten a message. I just had jitter initial, that's too bad. Thought I would have gotten something. Alright, and so now we're rendering, believe it or not. And one way we can tell we're rendering is, where is that stupid frames per second thing? There it is. This is like a frames per second meter, right? We use this to look at matrices. This is my frame rate. And you see how it's like almost 60? That's a refresh rate of the projector. That's NTSC 60. So it's 59.97 or whatever. 59.94 frames a second, right? So that's how many frames I'm going to get, right? You can go lower than that, you'll never be able to go higher than that, because it's locked to the render cycle of the graphics card, right? There are ways to go higher than that, but it's if you would use it for rendering, you would actually turn off the window. Okay, so far so good? So we got that out. And now we got to put some stuff in there. So, and I'm going to make it so I can make the window go full screen. So let's do that first. So I'm going to make it so like when I hit, I've done this before, when I hit the escape key, I'm going to hit a toggle box, on, off, great. And that's going to send the message full screen 1 or full screen 0 to the window. And that's going to take it full screen. You know, boop, 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 so we can see what we're doing big. I'm going to save this. My first OpenGL. Okay. And so now what we're going to do is we're going to stick some stuff in there. Really easy thing to stick in there is something called GL grid shape. Alright. There it is. You give it a name of the render context you want it to do, right? So again, these guys don't have to be connected. They're all called Bob, alright? So they know about each other. And basically what's going on under the scenes is that OpenGL is a client-server model. So what happens is every time the renderer gets a drawing message, it sends out a message to all its clients, like this guy. It says, hey, what are you doing? What are you doing? What are you doing? And this thing tells it, drawing like a circle. And this thing says, okay, renders it, rasterizes it, and then tells the window, hey, I'm done, show it. That's basically how it works, right? So this person, the renderer gets a message to draw, calls out to all the clients, figures out what's up, renders it, then connects to the window, and the window shows this, right? Rinse, repeat, rinse, repeat, rinse, repeat. So it's like, you know, 1, 2, 3, 1, 2, 3, 1, 2, 3. Does that make sense? So this thing is like a circle. I can take it full screen, and we will see it kind of looks like a circle. It doesn't really look like that good of a circle. It's kind of a jagged edge, right? But we'll work on that. OpenGL objects have tons and tons of very common attributes that they often all share, right? So like a pretty common one is I can turn on something called lighting. Lighting enable 1. Alright? And you see that? Now it doesn't really look like a circle anymore. Maybe it looks like a sphere. If by sphere you meant like sort of you know 1970s George Lucas style graphics, right? So it's kind of like that thing. I could try to make that look a little bit different by turning on something called smooth shading, right? And now you can see it's been cleaned up a little bit, so it's still like a sphere, but it's not as faceted. Smooth shading is the thing for the graphics card. It tells it to interpolate the vertices to make them look a little better and smooth things out. That's actually a shader. That's a default shader. It's shading the thing. Okay. So I turn that on. Lighting enable 1, smooth shading 1. Another thing I might want to do is change the color. Color in OpenGL is, I'll write this down, is red, green, blue, alpha, 0 to 1. Okay. Color in OpenGL, let's just write this down, OpenGL is red, green, blue, alpha, 0 to 1, alright? So this is red, okay? 1, 0, 0, 1 is red, alright? All up on the red, no green, no blue, all up on the alpha, alright? The alpha is the transparency. Because there's nothing behind this sphere, if I turn down that alpha, you'll just see it get darker, but it's really actually getting more transparent, right? It's just getting transparent to what's behind it, which is like gray, it's getting darker. Okay? So that's it. And then there are like these other ones, and you can change all these dynamically, but like there's something like scale. Scale is a fun one. Scale takes 3 numbers, right? It takes X, Y, and Z. Okay? So I can change its size. Let me shrink it. Okay. Shrink it way down. There's a problem, and we'll explain what the problem is in a sec. So I just made it small, and I can make it big, and I can shrink it down again. But you see how like something's wrong, like it's not getting small again, it's only getting big. I can make it bigger, but not smaller. See what's going on? There's like something's wrong. And the reason for that is because I'm never erasing the screen. So what's happening is I'm not erasing the screen, and it's doing something called depth testing. So it's not drawing things that are inside of or behind other things. And so the biggest, closest to the camera or whatever stuff, like stays, and you can get rid of it. So like the way to get around that is you say to the metronome, every time it goes off, you say erase, and then bang, right? You tell it to erase, right? You're manually, in OpenGL, you're manually, so now I can shrink it and make it big, right? In OpenGL, you're manually in control of your own erasing, right? Because, right, you could use this as a drawing machine, right? I can make this thing small, like that, you know, like that, like that, see that? And I could use it like a paintbrush, right? Just by moving it around on the scene, if I don't erase, then I'm like drawing, right? It'll stay where it was. You get it? So like you're in control of your own erasing. You can do it either way, right? So that's fun. The color it erases with is something called the erase color. You give it to the renderer. It's like kind of a big picture thing. I'm going to make the erase color white so it's easier to see. The default erase color is some kind of charcoal gray. It's like 0.2, 0.2, 0.2, something. I don't know. So now the background's white, right? That is basically the color that it fills the screen with whenever you send the message erase. That's all. All right. So scale is X, Y, and Z, right? You can do them independently, right? So I could say let's get like 3 number boxes, and let's join them up somehow. PAK is something that will join 3 numbers and will fire no matter which one you move. It's just kind of a handy thing. It's good for testing. Another way to do that is you can say join 3 at triggers. Don't do that. Just say PAK. And so I'm going to say scale $1, $2, $3 now. And now I've got independent X, Y, Z. So 0.5, 0.5, 0.5. So check this out. So if I change the X scale, right, I can do that. If I change the Y scale, right, if I change the Z scale, right, it'll get crushed. See what it just did? It turned into like kind of like a junior mint. And now it's like coming toward you, right? That's its Z, that's its like thickness. Does that make sense? And you can do the same thing with like position, right? So you can move it around. But position, $1, $2, $3. So let's move it around. So this is like, let me make this a little small. So like this is its X position. Whoops. So I can move it left to right. I can move it up to down. I can move it closer to you and farther away. Okay? This kind of looks like it's scaling it, but it's not. It's actually moving it. Right? So this may appear like I'm just changing the scale, but I'm actually moving it closer to you. And you can tell, like if I shift the Y up and I move it closer, see it'll go above my head. It really is like 3D. It's going to pass above my head, or it'll pass below my feet if I make it far down enough. Right? So the default position of anything is 0, 0, 0. And the default scale of anything is 1, 1, 1. Okay? Position is a little bit complicated because what it really depends on is where your camera is. Okay? So there's a default camera, and cameras have kind of 4 or 5 different things they need to know. They need to know where they are. They need to know what they're pointed at. They need to know their lens angle. They need to know their up vector, which would be like, you know, is the camera like this, or if you turn it sideways, right? All that stuff. But the default camera lives at 0, 0, 2, pointing at 0, 0, 0. So at the center of the world, 0, 0, 0 is the Sharpie. The default camera would be like here, right? Like 2 units in front of it, right? Pointing at the middle. Okay? So the position works, right? This is the X position, this is the Y position, this is the Z position, right? Where it gets a little fucked up is if I moved my camera
let's say 2, 0, 0, looking at 0, 0. Now the X actually moves toward me. Y still moves up. Z moves left to right now, right? If I twist my camera 90 degrees, X moves toward me, Y moves left to right, Z moves top to bottom, right? So it depends on the camera, right? So you can actually, like, you know, by changing the camera, you can make it so that all of these numbers, the position numbers, no longer, like, relate in the same way. You guys get it? Like, something to keep in mind. Position, in other words, the position coordinates are absolute within the world, so you have to keep track of your camera. But you can leave the camera on. The third one that might be kind of fun to play with is you can also rotate, right? Rotate. Rotate is actually 4 numbers, which is fun. Right, let me label these. So, like, position is X, Y, Z. Scale, also X, Y, Z. Rotation is angle, and then X, Y, Z vector, okay? So the way it works is the last 3 numbers, okay, determine the kind of axis of rotation, and then the first number is how many degrees. So if I say like 1, 0, 0 here, it's going to turn, you know what, we're going to change the shape. Grid shape takes more than one shape. The default shape is a sphere. I'm going to draw a torus, which is a fancy way of saying a donut. Okay, look, I'm drawing a donut. All right. So if it has like 8 default shapes. You can do a cube, you can do a cylinder, you can do a plane, whatever. So if it's X, Y, Z, 1, 0, 0, it goes like this, right? It goes head over heels, okay? Because it's spinning around the x-axis, right? These are degrees, so 360 is the same thing as 0, all right? If it's 0, 1, 0, it's going to go like this. It's going to spin like a top. Get it? If it's 0, 0, 1, it's going to twist, which is kind of hard to show. You're going to have to sort of take my word for it. It's spinning this way. Okay, it's twisting this way. Actually, let me make this thing a cube for a minute. You'll see. Cube. Whoops. Get small. Okay, thank you. So, yeah, so see, no, that didn't work. Rotate 0, 1, 4. That's why. So see, we'll go this way. Right? You can do everything in between, right? So like I could just make up some weird angle and it will spin in that vector, right? Wherever that line is. Get it? So like you can sort of define your own thing. So like one thing you would maybe do, well, I got a good idea. Let's make a thing. Remember how like I made a sub patch last time, or a couple times ago? Yeah, like where the fuck is the mouse or whatever. So we're gonna make a thing using. There's this totally awesome object called drunk. Okay, and drunk is kind of random, but it's actually got 2 numbers. If you're a math geek, it does something called Brownian motion. But basically, the first number, okay, so like drunk is just like random. You give it a range, so 1,000 means it's going to give you numbers between 0 and 999. All right. So like you hit it the first time, it's like full on random. But then the next time you hit it, it's random, but it can't be more than this second value away. So it's going to be like it can't be more than 20 on either side. Right? So it kind of does like, it's called Brownian motion, it does like a random walk instead of random like noise. Yeah? So we're going to try this, alright? We're going to make ourselves, yeah, alright. So let's say I got an inlet, and this inlet is going to get some bangs. Okay, bangs. And we're going to have a drunk, it does integers. So we're going to say, okay, I want a drunk number here. I'm going to say, alright, you give me numbers between 0 and 999. It's going to be position. So I'm going to make them go from -1 to 1. I'm going to do the x, I'm going to do the y, I'm going to do the z, x, y, z. I'm going to join them together, and I'm going to say position $1, $2, $3. And that's going to go out an outlet. Okay? And we're going to save this. Ugh. And we're going to say, we're going to call this my drunk object. That's not how you spell that. Object. My drunk object. Okay. We're going to save this in something else. Save as drunk objects 1. Alright. So I'm going to hold my breath, wipe all this out. Hardwire. Do I want a cube? No, I want a donut. Of course. And I'm going to hardwire the scale to be kind of small. I'm going to make it tiny. That's pretty tiny. Okay. And I'm going to say my drunk object. Okay, so found it. I got an inlet. And I got an outlet. I'm going to hook this up. And now I got to bang it. So I'm going to modify this and replace it with a trigger. I'm going to say, look, bang, bang, erase. So every time the metronome goes off, I'm going to erase the renderer, bang the drunk object, then draw the renderer. Okay? And now my donut has some issues, okay? So this is like the flow. Let me colorize this so you guys can see where it's going, all right? So all the stuff going to the renderer, we're gonna make purple. And then all the stuff going to the object, we're gonna make like the opposite of purple. That's not the opposite of purple. Green's the opposite of purple. Okay. Right? Sort of see what's going on?
If you just bang it, it will stay static?
Yeah, if I disconnect this thing, yeah. So like if I disconnect this, right, it'll just hang out.
Okay.
Right? This thing is not drawing it yet. This thing is just positioning it in between the draws. Alright? So what's happening is the metronome goes off, erases the renderer, updates the position, then this guy does the bang, which is just like what we said before, 1, 2, 3, 1, 2, 3, right? So this guy then draws it based on the new position and shows it in the window. If I turn off the erase, right, now, this is what I was talking about, right? You're in control of your own erasure cycle because you can use OpenGL like a canvas, right? And any shape can be your sort of paintbrush icon, right? You can draw with it, right? So now it's just kind of hanging out and doing this.
Can you just open my drunk project again?
Yeah, sure. So what we got here is we got a bangs coming in and that position message coming out. I got three drunk objects picking random numbers between 0 and 999 in this kind of do way. And I'm scaling them to between -1 and 1 so that it's kind of like germane to the 3D space. Right? Right?
Join and not pack.
It's the drag. Okay, so let's save this. Alright, so join versus pack without a C. I know this is a drag, alright. This is because the problem is that the really annoying thing about Max is it's 25 years old, 27 years old. It's a programming language that's older than some of you. So there's some idiosyncrasies about it. And so the people who wrote the programming language in Paris in the 80s were really into this object called pack, right? Where you had to type it. You had to like actually say like what the data types were. So this would make a message out of like a floating point number, an integer, and a floating point number, right? If you sent a floating point number into the middle outlet, it would get cut into an integer, all right? And it'll only put out a message on the left-hand inlet. So if I drag this around, nothing happens. If I drag this around, nothing happens, right? If I move this, something happens. And you see how the middle guy got turned from 2.3 into 2? That's because I didn't put a dot there. It's an integer. All right, so pack. a few years ago, we decided that was a drag, so we made one called PAK, which does the exact same thing but fires wherever the hell you know, it doesn't matter which inlet. This is good for debugging, right? That's why we were using it in that previous patch, right? So like the position message or whatever. And then, so the job I have for this company is I write memos and nobody reads. But one of the ones I read is then I propose a thing called join. And join basically like doesn't give a shit what comes in. The number is just how many inputs it has, right? And it'll just leave them alone. And just like path, it'll only fire on the left, but if you want to, you can customize that with an attribute called trigger. So if you say trigger is -1, it'll fire on all of them, just like this. So these, this equals this sorta, and this equals this, sort of, right? Does that make sense? So it's like, you know, the thing is, there's all these like ways to do different things, but I'm a big fan of join, because then I don't have to remember whether it's going to be an integer or a floating point number coming in. It's just going to take three things and whap them together, right?
What's the advantage of having fire on the left?
That's a max thing. You want that usually, because the objects that do something usually want to fire on the left, right? So like think about it. If it fired on every one, this would send a position message 3 times every bang, right? You would get like a random number in here, and then it would reposition the thing. Then you would get a random number in here, and it would reposition the thing. Then you get a random number in here and reposition the thing, right? Which is wrong. You don't want to do that, right? You don't want to update the object 3 times when really you're talking about a Z, a Y, and an X, and you want them all to come together. You see what I'm saying? So you can always set up the data before you execute, right? Let's add some stuff to this. I'm also going to drunkify the color. So let's do that. We're going to do the exact same thing. Color, we're going to leave it opaque right now. This doesn't go from -1 to 1, this is going to go from 0 to 1. And I kind of want it bright, so I'm actually going to make it from like 0.5 to 1. This should make everything nice and pastel. Okay. Alright, there we go. So now my donut's changing color. You guys see that gradually? Right? It's going to go like kind of blue, and now it's going to go kind of purple. Hopefully eventually it'll change to something else. I'm not really sure. And now it's blue again. Did I forget something? Where'd it go? Oh, it's off the bottom of the screen. It's kind of white right now. Let's get in there. Okay, and then I'm gonna, what am I gonna do? I'm gonna rotate it too. Okay. And I'm gonna rotate it in a slightly different way. All right. So what I'm gonna do, this will be fun, is I need 4 numbers, and that's rotate. Rotate. Join 4. And so what I'm going to do is I'm going to use a random object. Random, thousands, and I need one more. Just let me go over there. Get it. And I'm going to load bang these guys. So these guys are going to execute once when the patcher loads and pick an XYZ axis for it to spin. And then the way this is going to work, alright, watch this. I'm going to grab a number, I'm going to grab an object called a float, or an F. You can also say float if you want. And the way it works, it's pretty cool, is you send a number into the right-hand side, okay, and it holds onto it until you bang it. So oh, I'm banging it, so I should not do that. Bang, go put it out. It's kind of like holding onto a variable almost. So like I set it to 0, I whap it, I see the 0. I put in numbers all I want, it'll only hold on to the last one when I bang it. Okay? So it is kind of cool because what you can do is you can take the number add like, I don't know, 0.5, 0.2, 0.1, I don't know, to it, right? And then I'm gonna mod it by 360. You guys all understand what that means?
No.
The percent sign. This gives you the remainder of a division, so this will keep it in that range, right? And so what's gonna happen is, watch this. And then I'm going to feed it back in. Okay? Check this out. I just made a counter. It's going to go continuously from 0 to 360 and then back. Right? Because it's like a feedback loop, right? Every time it bangs, it puts out the number, adds 0.1 to it, wraps it around 360, and stores it back in there. Right? So this, first of all, it's too fucking slow. Alright, so we're going to make it like 0.7. Whoa, 0.7. So we're going to do this. We're going to hook this up. We're going to hook this up. And now, if I did this right, and I think I did, it's spinning. It's spinning around a random axis. It's hard to see, so let me make a new one. Every time I recreate this object, it will pick a new rotation. There we go. See how it's spinning now? It's like, you know, spinning according to a whatever. Alright. So I like that. So here's the trick though. Here's the trick. The way it gets cool is this. Alright. I'm gonna save this. Drunk objects. Objects 2. Alright. I'm gonna tell the grid shape. I'm gonna turn off something called automatic. And so this like scary thing's gonna happen where it's gonna disappear. It's not there anymore. It's gone. It's gone. Okay? Automatic is the flag that makes it get drawn every render cycle automatically by the render object. If I turn off automatic, I gotta draw it by hand. And the way you draw it by hand is by you sending it a bang. Okay? So in my drunk object, the very last thing here, I'm going to add the position, I'm going to say comma bang, and it'll come back. Alright? So, and I'm going to save this and call it my drunk object 2. Alright? My drunk object 2. So now it'll be back. And it's back. Okay. Alright? So all I did was after I make a drunk position, right, I say draw. So it's like pick a rotation, pick a color, set the position, draw. Now here's the cool part. Pretty cool. The cool part is pretty cool. I am going to hook up. Can I do that? Holy shit, that worked. So cool. I'm holding down like shift and like 800 other things, and somehow it's coding. Wow. You can keep the color though. Whatever. So we're gonna hook up the bang to all this. Watch this. Alright, 4 shapes. 1 grid shape object. Okay? So here's what's going on. Right? Metronome goes off. Erases. Sends this bang to these guys. Alright? Each one of them, right, is internally in its own logic updating a color, a rotation, and a position, sending them out to here, and then saying draw. Okay? Then the next one goes, sets it up, draw. The next one goes, sets it up, draw. You can draw this thing as many freaking times as you want between the erase and the main bang. And it will just keep putting it in different places. This is actually how you're supposed to do procedural graphics, right? Because this shape, this geometry, this torus, is uploaded on the graphics card. So if I want to draw like 10,000 fucking donuts, you shouldn't update 10,000 shapes of donuts. You should just upload one shape of a donut and draw it 10,000 different places every frame, right? That's more efficient, right? The thing will run out of memory if you try to upload 10,000 different donuts. You get it? Mm-hmm. So it's called geometry caching, right? It's the same thing like when you play a first-person shooter game and there's all those walls. There's only one fucking wall.
there's wall, it's probably called wall, and it gets drawn like 100 times in the scene every frame, in different places at different angles, right? And that saves memory on the graphics card. It's much easier to tell a graphics card to do a bunch of things with the same resources than to upload a ton of resources and only use it 20 once, right? So that's kind of the deal. So what I'm doing is I'm drawing this thing, 4 times, right? You get it? Kind of cool. Okay. So I think this is kind of nauseating. And just to drive the point home, I'm going to make a few more of them to just make it extra nauseating. Let's just make some more. I like this. I like that. I like that. I like that. I like that. You go here. Yeah, you and you and you. Holy shit! Look at all these times. All right. So I think they're kind of like, you see what I'm saying with the drunk, right? So how do you smooth things? Kingdom for an eraser. How do you smooth something?
Interpolation.
Yeah, what's that mean?
Kind of like average the difference between the two values.
What two values?
The old value and the new value.
Right.
Over a period of time.
Right. Everybody hear what he said? Does that make sense? You want to smooth things, you look at how things are changing, right? And you interpolate those values. You do some procedure on a new value and some old values such that the result ends up to be somewhere in between the two, right? The generalized form of that would be something like a filter, right? So this is going to be, we're going to make a filter. So like, for example, let's say, so like one simple way to smooth something, right? Like say I have a sensor. Imagine this is data coming off of like a sensor, and the sensor is noisy. You guys know what I mean? Like you're reading a microphone.
Yeah.
Do with a microphone. Here, I have to smooth this. This will make it really easy to see. I'm going to get rid of that stupid little NX sticker. Bug. Come here. We're going to do this. I'm going to take a break. So, you know, like I got that thing I do where like I shout into the computer. So we're going to do that again real quick. Metro, PCamp, ADC, this is the number box, and that! There it is. Okay, so that's my voice. Right. If I want to plot this, you know, there's an object called multi-slider. It's somewhere in here. Yeah, that's what it looks like. It looks like a bar graph. And it has like a million options. But one of the very cool options it has, it says range from 0 to 1, is that it has this thing called reverse point scroll, or reverse line scroll. See reverse line scroll. You see that? So it's kind of like a running bar graph, right, of what's coming in. Just for show, right? Okay, so that's like the volume of my voice being plotted. All right. So if I wanted to average this, average this. All right. So if I want to smooth this, all right. One thing I could do, if I felt like it, is I could take this very cool object called bucket. And bucket always gives you the last number, right? So if I send in, what's going on? It's always giving me the last number I put in, right? So it starts out as 0. So I send in a 5, it puts out a 0. I send in a 2, it puts out a 5. I send in a 10, it puts out a 2. I send in a negative 55, it'll put out a 10. It always gives you out the last thing you put in, one step back. You can think of this technically as one sample of delay. Important, right? So this is like one sample of delay. And so what I'm going to do is I'm going to take
And I'm going to use trigger for this, because we know how to use trigger. I'm going to do a float to float. And I'm going to take the previous value and the current value. I'm going to add them up. This is going to add, right? Then I'm going to divide it by 2. Okay? And I need a number box. Let's see what's going on. See if this is any better. Okay. So what this did, okay, was this took these numbers and averaged them with the previous value, right? So if we shut off the metronome and I draw this by hand for a minute, right? Right? Look at this is the output of the filter. So if I'm sending in zeros, everything's hunky dory. I send in a 1, I get a 0.5, right? Because half 1 and half 0 is 0.5, right? It's looking at the previous value. I keep sending 1s, it'll go up to 1. I drop down to 0, it'll go to 0.5 again, and then stay at 0. Does that make sense? So it smoothed everything over one sample. Yeah?
So you can add multiple of these buckets and create a...
Yeah. And create a smoother filter. Yep, that would be one way, right? So to generalize this, right? Like if this were, so like a way to generalize this would be to say, let's give this a variable. Let's say x is the stuff going in, okay, the input. Y is the output, okay? And n is now, okay? All right, let's think about that for a minute. So what I'm saying with that little circuit down there is I'm saying y sub n equals x sub n plus x sub n minus 1 over 2. That's what I'm doing, okay? Take the number coming in, the number that came in one time ago, add them up, divide them by 2, that's your output, okay? This is called a non-recursive first-order low-pass filter, if you're into this. Kind of stuff. So if you want to impress some electrical engineers, this is the other class I teach at the engineering school. It's digital signal processing, and this is all we fucking do. So what this does, okay? If you were listening to this, all right, it would cut the highs. It would be like the tone knob, a passive tone knob in an electric guitar. That's what that does, right? And you know, if you know analog circuit design, a delay is a what? What makes a delay in an analog circuit?
0.
What?
1.
Yeah, or like in a voltage, right? How do you delay something? That turns them down. The other one. Capacitor. Capacitor stands for capacity, holds on to voltage, and then lets it out. Once it's full, that's a delay. Okay? So the tone knob on your guitar is draining, is siphoning off stuff through a capacitor and mixing it back in. That's that circuit that cuts the highs. Okay? That's what that does, right? The value of the capacitor will change the tonality of that roll-off.